So we have our 10-4, day 2. We're going to find the inverse of a linear function, and we're going to do that algebraically, okay? This is kind of an intro. You'll do more inverses in Algebra 2, and we'll graph them and do a lot more with them. Right now, it's just kind of an intro, just a taste of what it is, okay? And we kind of already started doing it the other day when we were switching our x and y values, okay? This is just going to be when you're given an equation. Well, how do we do it? Because yesterday we were given points or a table, and that's kind of easy to just flip-flop them, right? So we're going to learn how to do it algebraically given just an equation. So just to recap, the inverse does switch our x and y values, which means if our x and y values switch, then our domain and range also switch. Because if the x's were my domain and now they're my y's, then it makes sense that my domain will switch to my range. And so it'll flip-flop. The inverse of a linear function is also a function, so it'll pass the vertical line test. We did that in the first semester. And the graph of G is a reflection of F. The line y equals x is the line of reflection. And so this is just kind of some info on what an inverse is and what it looks like on a graph, and what domain and range and how that changes, okay? So if we look at this guy here, I want to talk about this guy real quick. I'm going to zoom in on him. So this one right here, this blue, right, that was our original linear function. It's a line. This dotted line is our line of reflection. So let's add that. Line of reflection.
And does the line of reflection change on where it is?
It doesn't. The line of reflection for an inverse will always be the same line. So that's pretty cool, okay? And just like, remember how our axis of symmetry mirrored the points? That's what the line of reflection does. It's just on an angle this time instead of straight up and down. And so any point on the line of reflection doesn't move. But if I look at this blue one down here, see how it reflected across onto the red one? This blue one up here reflected across onto the red one. This blue up here reflected across onto the red. And last one, blue, reflected across. And so visually, this is what an inverse function and a function will look like. Okay, they'll always kind of be folded. If we folded it diagonally on the graph, they'll match up, okay? So here's how we find the inverse of a function algebraically. We're going to change our f of x to y. We did that yesterday, remember, on those last 4. Step 2, we're going to switch the x and y because by definition, the inverse says the x and y switch places. So our second step is we're going to switch them. Then we will solve for y. Once we solve for y, that will be our new function. That'll be our inverse function. So for this guy, I'll try and keep the instructions in line. Find the inverse of a linear function. So we have f of x equals 3x minus 9. So step 1, we write y for our f of x. Okay, that's the only thing that changes. Step 2, now we switch places. X goes here, y goes here. Nothing else changed. Still the 3 is there, still the minus 9 is there, okay? So now step 3, solve the equation for y. So I have the y here, it's being multiplied by 3 and subtracted by 9. Which one do we move first? Yeah, plus 9, awesome. Plus 9. Plus 9.
And then put the x plus 9 over 3.
Good. Y over 3.
Divide by 3 because of the multiplication happening.
Yeah, we're multiplying the y by 3, so we have to undo that by dividing. Awesome. And we can put that guy over 3. Now, I can choose to leave him this way, or I can simplify him just a little bit further, okay? I'm going to go up here since I'm running out of space. X plus 9 over 3 equals y, right? Because my 3's canceled. So this is, I have my y by itself. I'm perfectly fine leaving it this way. If you want to go a step further, Just because I see that the 9 and the 3 can reduce a little bit, that's helpful, especially when you get into graphing it later on, okay? What coefficient's with this x? 1. So since there's a 1 here, we can write it as 1/3 x plus, what's 9 divided by 3? 3 equals y. And that's our inverse. So what's our first step for number 2?
You have to make it equal.
F of x equals y.
Yep, we got to replace that f of x with y. Good.
No, you
Careful.
can switch the x and y.
Yep, you got to switch them.
Oh, I already did.
X equals, we'll catch up with you, equals 4y minus 2. So then, what did you say? Add 2. Add 2. So we have x plus 2 equals 4y. Then what?
Divide.
Divide by 4. Divide by 4. And you can leave it as x plus 2 over 4 or simplify. Yeah. Is it?
1/2 x.
Careful, 1/4 x plus, what's 2 over 4?
2 or 1.
That's your 1/2.
Oh.
Yeah, you were doing it a little too soon, so just be careful, right? Because,
There's a 1/2 coming.
yes, the 2, 4 simplifies to 1/2. Very good. Okay? But like I said, I would be fine leaving it as x plus 2 over 4 as well. This form is just a little bit easier when you guys start graphing because then you can see your slope, you can see your y-intercept a lot easier. Okay? Let's do another.
Okay, make the f of x y.
All right, make it a y. Got it.
Switch places with the x and y.
Switch them. Check. Well, almost check. Hold on. Okay. Then what?
Subtract 14.
Subtract the 14. Awesome.
That'd be x minus 14 equals 7y.
Nice.
By 7. Put the entire thing over 7.
Good. So we could leave it as x minus 14 over 7, or we can simplify. Remember, there's a coefficient of 1 with that x, so you can write it as 1/7 x minus, what's 14 divided by 7? 2. And so we have y equals 1/7 x minus 2. Okay. Have some negative x's now. It's not going to throw us off, though. I believe in you.
It's a negative 1x.
Yes. So still replace, right? Replace it with y. Still switch.
Subtract the 8,
Good.
put the entire thing over -1 equals y.
Good. If I have a negative y and I put everything over a -1, what happens to all the signs? Yeah, they just all change, right? So right, because that's a -1. So if I put it all over -1, this one I definitely would expect you guys to simplify. If it's being divided by -1, because all it does is change that sign. So the positive x becomes a negative x, and the -8 becomes a positive 8. And our negative y became a positive y. So I think with somebody in my second hour, somebody in my second hour said, well, if you just have a negative y and you want to change that, then just change all the signs. It's the same thing. That's what we're doing when we divide by -1. We didn't change the number itself, just the sign. Yes, you guys can do the last two by yourselves.